Hello everyone and welcome back to the YouTube channel, and today I'm going to talk to you about rational and irrational numbers part 1. So in this video we'll be only discussing about rational numbers, and then the next part we'll be discussing about the irrational numbers, okay? So the first, before we go to rational and irrational numbers, the whole number system consists of imaginary as well as real numbers. So imaginary numbers can be, for example, root of -4 and root of -5. So here we know that there is no real root for -4 as well as for -5. They're just imaginary roots. That's why these numbers comes in the form of imaginary. While for root of 4, a positive root number will have a positive number here. See, 2. So root of 4 is equal to 2, which is a real number. This is a small flowchart of real numbers. So here we can see real numbers consist of rational numbers and irrational numbers. Then it's further divided into integers, non-integral, rationals. Then further more divisions it can be seen. So in this video again, I'm repeating that in this video again we will only look for rational numbers. In the next part we can see about the irrational numbers. So moving on, what is rational number? I know a lot of you might know what rational number is. You must have learned it earlier in your smaller classes. Well, rational number is represented by the letter capital Q, and it is a number that can be expressed as A by B, and A by B is a rational number. It can be a fraction, it can be natural numbers, it can be whole numbers, integers, all that sort, okay? And here A and B are integers and B is not equal to 0. So this is represented in this conditional format where Q is again rational number and A by B is represented as rational number where A is also integer and B is also integer. Integers are represented by the letter Z, okay? And B is not equal to 0. Of course, denominator should not be equal to 0. If denominators are 0, then of course the number will be undefined, which is, you might have already learned about this before. For example, 4 by 5 and -8 by 3. Let's take 4 by 5 into condition. So 4 can be the letter A and 5 can be the letter B. Alright, so 5 is also not equal to 0. So anyways, this is a rational number. Also, you must take into note that 0 is also a rational number. This can be asked in fill in the blanks or questions like that. 0 is also a rational number, and that's how it's written: 0 by 2, 0 by 3, even 0 by 1, all that, okay? Okay, these are certain conditions that we need to keep in our mind. First one is that every rational number A by B, it also has negative rational number also. So even if it's negative or positive, it's still a rational number. For example, -A by B. This -A by B can be written in two forms like this. It can be A by -B, also this -A by B, okay? So don't be confused. Either of them means -A by B. This is an example that's shown here. And then we come to these two conditions. This condition is used to find if out of the given two rational numbers, which rational number is greater. We can find it by this method, which I will be explaining to you shortly with examples. Also, this condition is related to finding the maybe 2 or 3 rational numbers between given rational number. So these are certain conditions, and I will be explaining to you with examples now. So as we saw before on the different conditions, let me explain it to you more clearly by examples. We can use this condition to check if the given two rational numbers are greater or what, okay? So let's take 2 by 3 and 4 by 5 as examples. So as mentioned here, we have to do a cross multiplication. We have to multiply A times D and B times C. So here A and D is 2 and 5 and B and C are 3 and 4. So let's multiply 2 times 5 equals 3 times 4. So 2 times 5 is 10 and 3 times 4 is 12. Therefore, we know that 10 is less than 12. So 10 is less than 12 means according to this condition which is mentioned here, A by B is less than C by D. This will be the condition that follows here. So 10 is less than 12 means 2 by 3 is less than 4 by 5. So therefore it's clear that 2 by 3 is less than 4 by 5. That means the biggest rational number is 4 by 5. Okay, I hope that's clear. Now the second condition which we learned was this one. For any two rational numbers A and B, A plus B by 2 is a rational number. So let's just choose two rational numbers A and B. Okay, so A and B can be 3 and 5. Choose two numbers 3 and 5. Okay, and according to this condition, it's A plus B by 2, and here A will be 3 and B can be 5. So where we can do it, like, let's follow this condition. Why am I following this condition? Because in these given two numbers 3 and 5, we see that 3 is smaller than 5. So that can be the first step you can write. 3 is less than 5, which is this part, if A is less than B. So we have to anyways follow this rule, follow this condition. So 3 is less than 5 means, how can we write it again, as 3 less than A plus B by 2, which is A and B is 3 and 5. So 3 plus 5 by 2. 3 plus 5 by 2, which is again less than 5. So we'll write it as it is again. And 3 plus 5 by 2 is 8 by 2, which again when you cancel it will be 4. And 4 is less than 5. Okay, so this is one set of numbers, but we need to find at least 3 rational numbers between 3 and 5. So one of the rational number we found is 4. Now how can we find the other two rational numbers? We can do a step like this. We can do it as 3 less than, now we can take 3 and 4, we can add 3 and 4 by 2, and the next step will be 4, we can add 4 and 5 by 2. So like this, I will show you. 3 plus 4 by 2, again that's less than 4. Anyways, why we're writing 4 here? Because of this. So between 3 and 4 comes this one, that's why we are doing it this way. And again less than 4 plus 5 by 2, again that's less than 5. So I'll just maybe put space here so you can understand even better. Okay, so I hope that's clear. So 3 is less than 3 plus 4 by 2, then again less than 4, again less than 4 plus 5 by 2, less than 5. So here when we solve it, we're going to get two rational numbers in between. Okay, so let's see. It's going to be 3 less than 3 plus 4 by 2. What is 3 plus 4 by 2? That gives you 7 by 2, which is again less than 4. Less than 4 plus 5 by 2 is 9 by 2. 9 by 2 less than 5. So therefore your rational numbers between 3 and 5 are 7 by 2, 4, and 9 by 2. These are your rational numbers. You can also write it as, okay, wait, 4 comma 9 by 2. Okay, you can also write it as a mixed form. You can convert this improper fraction into a mixed form, and also you can write it that way. You can write it this way also. So this is an example on this condition. Alright, so now there are certain other conditions also. So always keep in mind that there are infinitely many rational numbers between each pair of rational numbers. So as we did before, we did with 3 and 5. So in between we only found 3 rational numbers. That's because the question was to find 3 rational numbers. But note that there are infinitely many rational numbers between any pair of rational numbers. So the second condition talks to you about x is less than 5. So how is that going to be? Is by using this little formula over here, and I will show that to you by an example over here. For this condition, this is similar to the previous one, but the main aim of all this is to find the at least two rational numbers between given rational numbers. So these are different ways. For the before way which we did it was called a mean method, and this is a different method. And there is also another method where we can do is an LCM method. You can find the LCM of the denominators and find it accordingly. You can find the number of rational numbers between two given rational numbers. So let me show an example on how to do this one. We can take the same numbers again, 3 and 5. Okay, let's take these both numbers, and here they have said d is equal to y minus x by n plus 1. So here we can put d as the times of the number we need to add along with this this condition. Okay, we need to find d first, so then we can evaluate into this one. So let's first write the formula, which is d is equal to y minus x by n plus 1. Here we don't know what is x and y, right? Look at here. Let x and y be two rational numbers such that x is smaller than y. So x should be smaller than y. Here 3 is anyways smaller than 5. So we have to make x as 3 and y is 5. Okay, x is 3 and y is 5. So now our aim is to find at least 3 rational numbers between 3 and 5. So we did the similar way in the previous method. So eventually you'll get the same answers, but these are a different way of finding them. You can do any method actually. So let's put it into this equation. Let's put x and y and all that into this equation. So since we have to find 3 rational numbers between 3 and 5, it can be anything, okay? So I'm putting the question as 3 rational numbers. Since we have to find 3 rational numbers between 3 and 5, I will put my n as 3. If it is finding 4 rational numbers between 2 numbers, it should be 4. Okay, so let's do d is equal to y minus x by n plus 1. So y is 5 minus 3 by n plus 1 will be again 3 plus 1. Okay, so once you solve it, 5 minus 3, okay, let's solve it together. 5 minus 3 is 2 by 3 plus 1 is 4. Therefore, 2 by 4 is 1 by 2. That's correct. So 1 by 2 is our d. It's not one of our number, but it's the d. So as I told you before, we will have to equate it into this given condition. X plus d, x plus 2d, x plus 3d. Since I said we have to find 3 rational numbers, our equation will be like this: x plus d, x plus 2d, then x plus 3d. Okay, so let's just substitute into this given equation. It will be 3 plus 1 by 2 comma 3 plus 2 times 1 by 2. Okay, because x plus 2d, that's why x is 3 and 2d means 2 times 1 by 2. Okay, next 3, because it's x plus 3d. Now x is again 3 plus 3 times 1 by 2. Okay, this is the equation. Alright, so after we do this as the equation, we can solve it. And after you solve it, what you can get is, after you solve it, you'll be getting 3 1 by 2. 3 1 by 2 is a mixed fraction form. I can't write it here like that, but it's a mixed fraction form. Then comma 4 and 4 1 by 2. It is the same answer that we got before. Before we only did it in the improper fraction, but if you want, I told you you can convert it into the mixed form, and here we did it in the mixed fraction. So this is the same answer as we did in the previous question, and I hope this step is clear and this condition is clear. So always keep in mind that you can do any of these two methods. Even there is a method called LCM. So that's pretty much easy. You might have learned it earlier. So you can use any of these 3 methods to find the maybe given 2 rational numbers or 3 rational numbers between the given rational number. So I hope that's clear to you. Okay, so now we're going to learn about some properties of rational numbers. These properties are pretty simple, so let's look at the first property. It said the sum of 2 or more rational numbers is always a rational number. So I'm not giving a write-up for this because it's easy, you can understand from the sentence itself. So let's consider two numbers, 2 plus 2, okay, or 2 plus 3. 2 and 3 are rational numbers. So if you add both of them, you get 5, which is also a rational number. And in this case, you can even put a fraction to see what kind of rational number you get. And then the second property tells us the difference of two rational numbers is always a rational number. Again, we can take it like 5 minus 3 is 2, but if you do 3 minus 5 is negative 2. So if it's a positive number or a negative number, it is a rational number. Always keep that in mind. Then the next one is the product of 2 or more rational numbers is always a rational number. Again, 2 times 3 is 6, or if you put it the other way around, 3 times 2 is also 6. So it doesn't matter if it's a negative product that you get is also a rational number. Even if you divide two rational numbers by a non-zero rational number, do that, okay? That means, what does this sentence mean? The division of a rational number by a non-zero rational number. This is similar to our definition of what a rational number is. Like a by b, where b is not equal to 0. That means the denominator should not be 0. Otherwise, the number will be undefined and it won't be a rational number, right? So that's what this means. Now there's the last part. We're going to learn about the decimal representation of rational numbers. So the decimal representation is divided into two parts, as you can see here. One is terminating, other one is non-terminating. The word itself says terminating actually means stop, or it's like put an end to. So in terminating decimals, there is no remainder. Once you do the division, there wouldn't be any remainder, and therefore that quotient would be known as terminating decimal. So for example, if you see here 1 by 8 is equal to 0.125, and it's stopped. That's it. It's not continuing anymore. Therefore, this is a terminating decimal. Now here, if you check non-terminating decimal, it keeps on going. That means once you start doing the division, it keeps on going. It's never ending. And therefore, such kind of quotient is known as non-terminating. For example, you can see here 3 by 7. That is equal to 0.428571. Again, it's repeating 428. So it keeps on repeating. Therefore, that's non-terminating. It keeps on going, okay? So there is a small thing on how we can find a rational number if it is terminating or non-terminating without doing an actual division. This is a common asked question in almost all the exam papers. So how can we do it without doing an actual division, just by looking at it or things like that? So this is a equation where you will have to equate it and find if that particular rational number is a terminating or a non-terminating decimal. So I will just show you how to do that. Okay, so now it's the last part that we're going to discuss for this part 1 of your chapter. Here we're going to find out like how can we find if a given rational number is a terminating or a non-terminating decimal without doing any actual division. So how is that possible? So as I mentioned earlier about the formula, which is 2 raised to m, 2 raised to m times 5 raised to n. Okay, 2 raised to m times 5 raised to n was the given formula, but how will you do it? So let me give you an example. Let's make our first question to be 17 by 50. How can you solve this? How can you identify 17 by 50 if it is a terminating decimal or a non-terminating decimal without doing the actual division? Just by looking at it or just by using the small little equation over here. How will you solve it? Okay, so take the denominator into consideration. So first, we're going to solve for the denominator. You will have to express the denominator into, like maybe find the multiples of 50. And therefore, it will be 2 times 5 times 5. After you solve it, you will get it this way. And therefore, you know what? We can express this into this equation, which is 2 raised to 1 times, and how many times 5 is there? 2 times. So 5 raised to 2. Since we are able to express this denominator in this form, we can say that the given rational number is a terminating decimal. So as I explained to you earlier, that if a rational number is being expressed in this form, then it is a terminating decimal. But if it can't be expressed in this form, then it is a non-terminating decimal. So keep that in mind. So this is an example of a terminating decimal. Now I'll give you an example of a non-terminating decimal. So let's just keep this number in our mind, 23 by 72. After doing the prime factorization and all that, prime factorizing the denominator, okay? So once when you do for 72, you will get 2 times 2 times 2 times 3 times 3. Okay, so just by looking at it, we can know that there is no 5 being included in the 72 factorization. So therefore, anyways, it's going to be a non-terminating decimal. If there is a 5 included somewhere here and not 3, then it would have been a terminating decimal. But then 72's factorization happens to be like this. So there's no other option. So how can you write it? 2 raised to 3 times 3 raised to 2. Yeah, therefore it's not in this format. It's not 2 raised to m times 5 raised to n. It's not in this format. Therefore, we can say that it is a non-terminating decimal. And I hope that's clear, and that's it for part 1 lesson.